Chapter 11, Section 3, Day 1 starts talking about probability of multiple events. We'll talk about how multiple events can occur together and calculate the probability accordingly. There are two kinds of events that occur. One is called dependent, the other is called independent. In a dependent event, one of the events will affect how the other one can occur. This usually happens anytime they say without replacement. So they don't put something back, they take it and don't put it back. In independent events, that means that one of the events does not affect the other. So they will say things like, we put it back, or with replacement. So if they pick something out of a bag, they look at it and they put it back. That means it's independent. So the following outcomes, are they dependent or independent? Letter A, rolling a number cube, then spinning a spinner. That is independent because the number cube has nothing to do with what the spinner will do. Letter B, pick one card from a deck and then your friend chooses another. This one is dependent because when you pick the card from the deck, that's one less card that your friend can pick, which makes it dependent on what you chose. Letter C, you pick a marble from a bag, you keep it, then pick another. So this one's without replacement, and without replacement is always dependent because that first marble is gone. Letter D, you pick a marble from a bag, replace it, then pick another. Replacing it is a very large key phrase here. Because you replace it, that makes these events independent because you look at the marble and then you put it back, which means your second draw is completely independent from what you did the first time. Letter E, a dime lands heads up and a nickel lands heads up. These are both two distinct coins, which means they're independent. One has nothing to do with the other. To find the probability of independent events, you find the probability of the first one occurring, and then you find the probability of the second one occurring, and you multiply those two fractions together. So, example 1, you toss a coin and roll a die. Letter A, what is the probability that your coin lands heads up and you roll a 4? So first do the probability that your coin lands heads up. So that's heads over total. There's one heads over two total options. Then do the probability that you roll a 4. So I want a 4 over total. There's 1 4, 6 numbers total. To find the final answer, you do 1/2 times 1/6, and you get 1 over 12. Letter B, the probability that your coin lands heads up. So we'll do that one first. That's heads over total. That's still 1/2. And the probability that you roll a number less than 3 over total. There are two numbers less than 3, just 1 and 2. And the total there would be 6. So you want to multiply 1/2 times 2/6. Your final answer is 1 over 6. Just to clarify, to get this answer, I did 1/2 times 1/6. To get this answer, I did 1/2 times 2/6. Number 2, a coin is tossed 3 times. What is the probability of the coin landing heads up 3 times? All right, well, the probability of the first time is 1/2, and then the second time is 1/2, and the third is 1/2. To get a final probability of 1/8. Seven cards are numbered from 1 to 7 and placed in a box. I'm just going to list them out so I can see them. Those are my numbered cards. 1 is selected at random and replaced. Pay close attention to the and replaced part. That's really important. Another card is randomly selected. What is the probability of selecting 2 odd numbers? The odd numbers here are 1, 3, 5, and 7. So the probability of picking an odd number first is 4 of them over 7 cards total. And then I replace it, which means the second probability is still 4 over 7. My final answer is 16 over 49. A spinner with 4 equal sections of red, yellow, green, and blue is spun twice, independent, spin twice. What is the probability that it lands on yellow and then green? So I need to do yellow and then green. The probability that it lands on yellow is 1/4 because there's 1 yellow over 4 total sections. And the probability that it lands on green is also 1/4 because there's 1 green and 4 total sections. Multiply them together to get an overall probability of 1 over 16. Two events that cannot happen at the same time are called mutually exclusive events. And if they're mutually exclusive, it means that the probability of them both occurring is 0. So you always have to ask yourself, can these occur at the same time? If they can occur at the same time, then they are not mutually exclusive. If they cannot occur at the same time, then they are mutually exclusive. And that can be kind of tricky. So take your time and consider whether they can happen. So you roll a single number cube one time. Can you roll a 2 and a 3? And the answer is no. You only roll one time. You cannot roll a 2 and a 3, which means that they are mutually exclusive. Letter B, rolling an even number and a multiple of 3. Well, the even numbers on a cube are 2, 4, and 6. And 6 is a multiple of 3, which means you can do it. You can roll a 6 and both of those things work, which means that this is not mutually exclusive. If you can do it, it is not mutually exclusive. Letter C, rolling a prime number and a number less than 4. The numbers less than 4 are 1, 2, and 3. And because of that, the prime numbers here, both 2 and 3 are prime numbers. So I can do it, which means it is not mutually exclusive. If you can do it, it is not mutually exclusive.